Hello everyone. So we'll continue with the session that we were talking about in the Python collection. So what we have done is we have completed out of five collection type that we have: list, tuple, and set. So today we are going to talk about the Frozenset. Frozenset is immutable and hashable. So once it has been created, its contents cannot be altered. But again, it can be used as a dictionary key or as an element for another set. So I'll take you through the examples that I've created for the Frozenset. Today I've already divided them into different sections. So for Frozenset, the first thing that we have to do is we might have a list, a tuple, or a set, and then that is what we are doing. We are creating a list, we are creating a tuple, we are creating a set, and that's what we have, the content of them. Then what we are also doing is we are placing in the Frozenset list, which is Frozenset, and Frozenset list is where we are putting the Frozenset keyword or the function, and we are changing the list x into Frozenset. Similarly, tuples is also being changed into the frozen tuple, and set x is also being converted to set x, and that's how it appears now. You can see that each of the Frozenset that we have created, it has a Frozenset name in front of it, and it has the circular and the curly bracket. If you print the type of any Frozenset, it will show you this information for the type. It used the same function like set that we did yesterday. Length would be giving you the length. If x is in S, so we can see that if one Frozenset is there in the another one, or might be a value of a string, or any value is numeric, alphanumeric, or those are there in that set. So we have written down that age in the Frozenset is true because it has consist of the age, which is because name, caste, and age. And 7 is the info set for 3, 4, 5, 4, and aluk. So that is not true, that's false, because it's not consisting. Similarly, if we check is not in S, so the previous example will just give us the opposite result because age is there in the Frozenset. So when we check it is not there, it says false because it is there, and because 7 is not there, so it gives you true. Then we are also checking about the subset. So I've created certain certain Frozensets as well after creating sets. Then what we are doing is checking that Frozenset odd is a subset of Frozenset x. Frozenset 1 to 3 is a subset of Frozenset x. Frozenset x is subset of Frozenset odd. Frozenset x is subset of Frozenset 1 to 3. So the first and the second is true, whereas the third and the fourth is false. And we will get the opposite result here because we are checking for the superset now instead of checking that if it is a subset or not. So we get false, false because this is not a superset of this. True, true because this is a superset of the values. The next is union. So union is that it will be showing you all the values. So we have two Frozensets. We are unioning them, or we are doing the union from them, and we are getting the values like all the values which is there in Frozenset even and Frozenset odd. It is coming in the union of Frozensets. Next is intersection. So intersection says what is there in a and P. So if we see that if the two frozen set don't have any common value, it is giving an empty. If the first frozen set consists of the second frozen set, then all the item of the second frozen set would be written. Similarly, in this case as well, 2, 4, 6 is written because that is common in both of them. S difference T, and this was very interesting. We were checking the differences. So if we see this and this is odd and even. If we find out the difference, it is equivalent to the first one. But if we take an example 2 in which set is 1 to 6 and frozen set odd is 1, 2, 3, 5. So if you try to find the frozen set difference, frozen set odd, it will give us 2, 4, 6. So the item which is not in the second one. Similarly, if we put in the even numbers there and then do the difference, it will give us the odd numbers. Symmetric difference, that's the beautiful method which gives you the value which is extra in both of them, like the way that we did in set. But again, if the values are consisting there, it will just remove those values from there. And what I've done is I have placed in this value as the net even as well. So net even I've not written. Frozen set X. No worries, I'll just copy this, paste it below it, and we will try to show the new set even as well here. So we see new frozen set is 2, 4, 6, 8, 10 and 12, and we are trying to do the union of it with, the difference of it from the frozen set S. So this is frozen set S. So now when we are finding the difference between, symmetric difference between them, we should have the values which are not common in both of them. For example, 1, 3, 5. 1, 3, 5 in this frozen set or frozen set X is not in the frozen set even. Yeah, so sorry, again we are just checking this with the frozen set. So this is the frozen set 1, 2, 3, 4, 5, 6, and what we have here is 2, 4, 6, 8, 10, 12. So if we do the or use the symmetric difference function, this is going to give us the values which are not common in both of them, but they are present in group A and group B. And these are the other functions which the frozen set does not follow. So that is what we have done for the frozen set. So in the frozen set, S update, S intersection update, S difference updates, S symmetric difference update, S add, S remove, S discard, S pops, and S clear, as I mentioned, are the method which are not applied on the frozen set, but they might have an equivalent methods available for the set. So all these methods would be available for the set as well. Then the below part is about dictionary, which we are going to cover tomorrow. So I think we have done some part of it, some good enhancements today. So with the hope that we have been able to move a bit forward in our learning, I leave you. So thank you for your time and thank you for listening. Have a wonderful day. Bye bye.